4-6. Any questions on 4-6?
Yeah.
Yeah.
Number
5. Is it? I don't know if that's true.
Wait, which one? You gotta be kidding.
Fortunately, you have to do 5. Alright, so I gotta find the equation of the tangent line. So this is 2. How do I find the y line? This slot. Plug in 2 to the original, right? So 4 minus 2 is 2. So you end up with like negative square root of 2 here. That's weird. Okay. To find that, I have to find the slope. So this right now is like negative 1 times 4 minus x to the 1/2. So if I take the derivative, negative 1/2, 4 minus x to the negative 1/2. And don't forget the times negative 1. I can see that being really easy to forget. It's the chain rule, so the derivative of the inside is negative 1. And then you could just plug in now. This looks to me, I don't know, I want to clean this up. You don't have to. I'm just doing negative 1/2 times negative 1 is positive 1/2. With me, Carter? And then plug in 2 here. So I'll get what? No, I thought I heard someone talk. So that'd be 4 minus 2 is 2. Square root of 2. 1 over 2 times the square root of 2. That's just annoying. And then I gotta plug 1.9 in there. So 1.9 minus 2 plus square root of 2. And I'm going to take advantage of the rule that, well, no, I guess I figured out. No, I mean, that's an approximation. I'm fine with that. Like, all that's left is division, subtraction, and multiplication. So it'd be like 1 over 2 root 2 times negative 0.1 plus root 2 if you want to go a little further. But if you can get to here, I'm fine. Oh, it's negative. My bad. I just forgot to carry the negative. Is that okay? Is it what? So if it was a calculator question, you'd probably want to like type it in and see what you get. But a non-calculator question, like they don't. So you can't leave like the square root of 16 because that's 4. But the square root of 2, like there's nothing. Any other ones on 4-6? Well, these copies. Is that what I said? Okay. Are you good? Yeah. 10. Did you get 10A? Oh, no, we don't have. So this is just, so you take the derivative like you estimated by doing like the slope between those two. Okay, t equals 4. You have to tell me how to move it because I can't show it all at once. This is basically like 4, 28 is the point they're giving us. And then what would go here is the slope when t equals 4. So the slope when t equals 4, you got to go back and look at. Okay, so we want, this problem's in centimeters. I want the derivative of that, which is centimeters per hour, right? So centimeters per hour is what this table is. So if you tried to like take the slope between these or something, between these 2 points, that's not going to work. I want centimeters per hour, so I want at when t equals 4, what is the slope? What's the centimeters per hour? So I'm just grabbing 2 from that table. So 2 goes there. And then, does that make sense what I'm doing? Yeah. And then I plug in 6. That's really far away, so approximate. Okay. So 2 times 2 is 4, plus 28 is 32. And then they ask if it's an underestimate or an overestimate. So I need to know about the concavity. So to check concavity, we haven't fully dove into concavity yet, but does it in the question? Gotcha. Okay. Okay. So I thought I was gonna go through that. Then if it's concave down, if the function is concave down, it's curving down, so any line we draw will go over the top. So that is an underestimate. Maybe how's that? Yeah. Other ones? Oh yeah. It would be over. Sorry, because I like drew it and said it.
Also, is IAT acceptable response for?
Yeah. That's not us, yeah. Intermediate value theorem. Should I look at B for a second? So is there a time when the depth is changing at 1.5? The idea is you can't get from 1.6 to 1.3 without passing through 1.5. And then what's that called? That's the intermediate value theorem. So you would say yes. Is there a time? Yes, there is. Since 1.5 is between 1.6, 1.3, and then just put like IVT. Others? Alright, let's do 4-7. Which is L'Hopital's rule. The hospital. That's like the joke on the backboard. That's Miss Mahaney's daughter. Why was I don't know, but there it is. It is nice handwritten. Okay. L'Hopital's rule is for limits, which is it's good to like at this point that you guys have probably forgotten a lot of the limit stuff we did, so this is kind of a nice refresher for that. And we couldn't do this when we did limits because you're taking the derivative in this process. We didn't know that at that time. So just remember, like in general, you would just try to plug in. So I'd go like 2 times 3 minus 5. Over 3, which would be 6 minus 5 over 3, or 1/3. This one, if I try to plug in, what's going to happen? Why ain't going to work? More than that. Top and the bottom are going to be 0. So if the top and the bottom are equal to 0 over 0, or infinity over infinity, either way. So I'm going to put 0 over 0. And what L'Hopital's rule says is that this is the same as if I asked you for this. You are allowed to take the derivative of the top and the derivative of the bottom, and then try your limit again. So this would look like derivative here is 2x minus 7. The derivative here is just 1. Now if we plug in 2, it'll work. So 4 minus 7 is negative 3 over 1. And I will get negative 3. So that's the magic of the hospital. And just to like prove to you that it works, the way we would have done this would be to factor it. Back when we didn't know L'Hopital's, I'd plug in 2 to what's left, and then 2 minus 5 is negative. So we're getting the same thing. And like from now on, if you see that question, you don't have to factor and cancel. You can do L'Hopital's. So it's up to you. Questions? I'm going to do the question. I don't think that's too bad. So the second one, you can't just automatically do L'Hopital. It has to be 0 over 0 or infinity over infinity. So you have to have one of those things. So if I plug in here, I will get 0 over 0. I notice that I'm writing it. If this is a free response in the AP test, which it doesn't tend to be, but I have seen it, you have to put the 0 over 0 there, and then you're going to say LH. You're kind of telling the person grading it, like, I know I got 0 over 0. I know that allows me to use L'Hopital's rule. And then you don't even need the d over dx stuff I had over here. You can just take the derivative, and you'd say that's the limit as x approaches 2 of 1 over 9x squared minus 12x plus 1. And then you would figure out whatever that is. So 36 minus 24, so 13, whatever 13. That's LH. It looks like an angle H, but that's LH. So multiple choice, obviously no one knows or cares what you put for your work, but for your response, you're going to put 0 over 0, core infinity over infinity. Right, LH for L'Hopital's, and then right, 3. If I plug in 0 right now, it says the sine of 0. Sine is y value, so what's the y value of 0 degrees? 0. I plug 0 on the bottom, I will get 0. Okay, I can now use L'Hopital's rule. So I'm going to take the derivative of the top, derivative of the bottom. So the derivative of sine is cos of 6x times 6, right? Because you got the chain rule piece. And then the derivative of x is 1. So if I plug in 0 now, the cosine of 6 times 0, or the cosine of 0, is the x value at 0 degrees, which is 1. 1 times 6 over 1 is 6. If you remember when we saw that back in the day, basically we just crossed off the x's and the sine, like that was our answer. We had like limit of, as x approaches 0, of like, let's say it was like 3 sine of x over sine of 3x over sine of 2x. That was that shortcut we learned that would be 2/3. And it's because of L'Hopital's. That's the way we get to that. Questions on 3? Right, 4. So same thing. Plug in, see what you get. Cosine of 0 is 1. 0, or then 1 minus 1 is 0. 0 squared is 0. So I'm good to go on L'Hopital's rule. And then I'm going to take the derivative of each. So the derivative of 1 is nothing. The derivative of negative cos, you guys remember that from the gateway, is positive sine. 2x. So now if I plug in, I get the sine of 0. What's the y value of 0 degrees? 0. What's 2 times that? What's 2 times 0? 0. So I can do it again. I got 0 over 0 again. So I'm just going to go down another layer. So what's the derivative of sine? Cosine of x. And then the derivative of 2x is 2. And finally I can plug in and I won't get 0 over 0. So cosine of 0 is 1. And then you get the 2 in the bottom. So if L'Hopital's doesn't work the first time, if you still get 0 over 0 or infinity over infinity, just do it again. Yeah, so it was like, it's just like number 6. So the rule that we said, I think, was limit as x approaches 0 of sine of ax over bx is a over b. Is that the one you're talking about? So like in this one, you just get 6 over 1 with L'Hopital's or that rule. All right, 2 more. 5. So if you plug in infinity now, those are just going to both get bigger forever and ever, right? If I plug infinity in for x, I've got infinity squared over e to the 2 times infinity. So I'm going to get infinity over infinity. That allows me to do L'Hopital's. And then I can say, okay, that's the limit as x approaches infinity of 4x, that's the derivative of the top, and then e to the 2x times 2, just don't forget the chain rule part, which is, okay, now if I plug in infinity, what do I get? I still get infinity over infinity, right? There was another way to do this, if anyone's like, why doesn't he just do this? We can do it a different way, I'll talk about it in a second, but let me finish this. So, this is really like 4x over 2e to the 2x. I'm just like rewriting that so I can take the derivative a little easier. All I did was move the 2. So what's the derivative of 4x? It's 4. The derivative of 2e to the 2x would be 2e to the 2x times 2. So the 4 and the 2 over 2 cancel, and I basically get 1 over e to the 2x. And if I plug infinity into that, what do I get? I get 1 over infinity, which is 0. Did anybody recognize from the jump what we could have done? No? Well, maybe. I don't know. Maybe that's a different way. Yeah. So if you remember, when limit is approaching infinity, you look at where's the higher power. And the higher power is in the bottom because 2 times infinity is a lot bigger than 2. And if the higher power is in the bottom, that's when you get like that 1 over infinity. And, you know, back in the day, we said that was 0, just like a different thought process. So now you have options. Questions on 1 through 5? So 6, all that they're doing there, I don't really see this a ton, that students get L'Hopital's and quotient rule confused. But I know on the worksheet, like the assignment for today, he throws in a couple derivatives. Remember that in derivatives, so is this true? If I said take the derivative and you told me this, does that work? Eric's shaking his head no. Thank you. Why doesn't it work? You have to do quotient. So L'Hopital's only applies for limits. If you're asking you to take the derivative, that's still a quotient, and you would have to do quotient rule for it. So L'Hopital's is limits, and quotient rule is derivative. Questions for me on that? Yeah.
Did you put any? Are there any quotient rules on?
I think that's about what this problem is.
So do you want us to actually do quotient rules?
Yeah. Do you want me to like review it? Do you want me to do one? You don't have to do the test prep for this section. So you got 1 through 15.
I like this one. So maybe this is my favorite one.
Yeah, this one's not bad.
Now I just want this constant.
So I also want, I'm going to add to your assignment. So I want you to do adding to your assignment. What is that? What is it? 1 through 15? And then unit 4 review. You're done with unit 4.
So when is our test? Oh, they says on Tuesday.
So that's this assignment. This is the like book review. Tomorrow, I'm gonna give you like I think it's like 42 questions that are AP multiple choice questions on this unit. You'll have tomorrow to do it. Like you could be ready for the test on Monday, but I'm not gonna be tested after like a 5-day break. So you'll have Tuesday and the Monday after break to work on that packet, ask questions, review, whatever, and then your test is Tuesday.
Is the test multiple choice or?
Probably not much of it.
I was running this. Maybe we can have a cheat sheet.
You can have a cheat sheet, but I'm not giving you like a user-friendly review where it's like, here's what I can expect. I'm sorry, that's not emotional. I'm not using the word. It's not integrated math. I trust you, AP. This is gonna be the worst.
I just don't know
Just 'cause we
how
haven't already-
these are. For me, I mean, it makes sense. Like, I can't like spend like, oh yeah, it's job. So I get why it's
You need
optional.
to go rating, not material.
Yeah, no, the material's not bad.
Well,
It's gonna have to go.
I mean, you could fix that if you look at it. Saturday,
Oh yeah.
Friday, give me something.
Let's look at it. Saturday, right?
Well, I mean, that's fine. Then don't complain.
No, I'm not.
You can fix the problem, is all I'll say.
Yeah.
Imagine studying.
That's mom.
People with better grades.
Yeah.
Now remember for the test, also you have to have all the problems in your books done if you want to be eligible for retake corrections, whatever it ends up being.
Not two months ago.
It's the gateway?
No, the one two times. Oh
They
yeah,
were,
yeah.
yeah.
Yeah, there were.
Yeah.
Did you do them? How there's no.
Sweet ones.
Because I remember Carter should have been like right after the gateway, right? The corrections.
Yeah, you did.
The corrections for the last unit, you turned it like right after the gateway, and you were like worried I wouldn't come. Am I not covering that?
No,
He
oh,
doesn't.
So we all remember except for him.
yes.
No. I remember. That was like that was the second test.
Yeah, you did correction on the second test right before, right after. You did it before.
No, I did it.
I know.
Right after, and then I never turned it in. The second day of the game. But now I can't look at hours.
Yeah.
Right.
Did you put the grades up for it?
Awesome.
It took me a second to see.
I can't say now. Yeah, I know that mine didn't go same, but I didn't know if that was